Today we will solve the problem 2.50 of Griffiths 4th edition Introduction to Electrodynamics. The problem 2.50 is the electric potential of some configuration is given by the expression V of R is equal to A multiplied by e power minus lambda R over R. Here you have to I want to stress this point that this is for some configuration. Earlier, we used to deal with the cylindrical or spherical or square, some shape. Here, shape is unknown. So, only thing is we know the potential. Where A and lambda are constant, find the electric field E of R, the charge density rho of R, and the total charge Q. So first we will start with the electric field. Electric field is equal to the negative gradient of the potential. So here potential is A multiplied by this factor. Since A is constant, you take it out. That is minus. Here you have minus A. This delta can be written as delta over delta R, this exponential term e power minus lambda r over r, r cat along the direction r. Then this is u by v differentiation. If you differentiate u by v, that is a derivative. I have used prime. I will use different color. This will be v du minus u dv divided by v square. So here u is this exponential term and v is this r denominator. First v is r du. If you differentiate this exponential term, you will get minus lambda, then e power minus lambda r. Then minus u is this one, numerator, e power minus lambda r, and v is dv. If we differentiate r with r, it is equal to 1, Now you have outside negative sign. So if you multiply this negative, all will become positive. Minus of minus is plus. So now you can take this exponential term over r squared as a common factor. That is e power minus lambda r over r squared as a common. Of course, r cat you have. And here you have a. Here the first term is r lambda. Lambda r, other thing we have taken out as a common. Then here you have only 1, that is e power minus lambda r over r squared, so this will become 1. So this can be rewritten as a into lambda r plus 1 e power minus lambda r over r squared r cat. Then we will move further. Now we got this expression E is equal to a lambda r plus 1 e power minus lambda r over r squared r cat. And now we have to find the charge density rho. By definition, charge density rho is equal to epsilon naught time divergence E. So epsilon naught you take as epsilon naught constant, then this divergence E, A is a constant, you take out, then divergence of lambda r plus 1 e power minus lambda r r cat over r square. So now if you take the derivative of this term, that is derivative of this, first you keep this term as it is, that is except r cat over r square. Here we can take the entire thing first. You keep this as it is, that is lambda r plus 1 multiplied by e power minus lambda r, then divergence of the second term, that is r cat over r square. Then you keep r cat over r square as it is, then you differentiate the remaining terms, that is divergence of lambda r plus 1 e power minus lambda r. Then what is this thing? Divergence of r cat over r is 4 pi epsilon naught delta q. Dirac delta function. 4 pi delta q of r. This is a Dirac delta function in 3 dimension. So you will have non-zero value only when r is equal to 0. So if r is equal to 0, this will become 1, because this is 0 plus 1, 1, and e power 0 is 1. So you will simply get 1. Only the remaining term is 4 pi delta power 3 of r, and you take the second term as it is. Of course, we have to reduce the second term. We will do it right now. Now we have seen rho is equal to epsilon naught A multiplied by 4 pi Dirac delta power 3 r plus r cat over r squared divergence lambda r plus 1 e power minus lambda r. Now you take this and the second term, then you find out the result. So I can take r cat over r squared divergence lambda r plus 1 e power lambda r. So this can be written as first you differentiate this exponential term. So this exponential term, you have lambda r. You can separate, first you can separate this into two parts. That is, you multiply, you bring e power minus lambda r inside. So first term will become lambda r e power minus lambda r. Second term will become e power minus lambda r. Just we brought this inside the bracket. Now we have to take divergence, derivative of this. First you take the derivative of the first term. If you take the derivative of the first term, then you keep lambda and the exponential term as it is, lambda e power minus lambda r, and differentiate r. If you differentiate r with respect to r, you will get 1. So this will be simply e power lambda e power minus lambda r. Then you keep r lambda r as it is. Then you differentiate e power minus lambda r, which you will get minus lambda e power minus lambda r. So if you multiply by this, you will get minus, here you have minus lambda square r e power minus lambda r. Then you differentiate this second term. Then you will get minus lambda e power minus lambda r. Now you can see the first term and the third term will get cancelled, because both are same magnitude but opposite in direction. And also now you can cancel this r with this r squared, which will become r. So you can take this as minus lambda squared e power minus lambda r, because r get cancelled, over r. Of course we have r cat. So now rho is equal to epsilon naught a. Epsilon naught a, you have that is what I am doing is I am going to substitute this value here, because we have find r cat over r squared divergence of lambda r plus 1 e power minus lambda r is equal to this one. That is minus lambda squared e power minus lambda r over r. Of course, r cat. Remaining thing I am keeping as it is. That is epsilon naught a 4 pi delta q over r, and minus lambda squared e power minus lambda r over r cat. Now we will reduce it further. So we have seen, ultimately we have seen the electric field, and we have seen the rho, that is charge density. So we got the uh, charge density, that is charge per unit volume, is equal to epsilon naught A multiplied by 4 pi delta Q of R minus lambda squared e power minus lambda R over R, of course, along R direction, R cat. Then our ultimate aim is we have to find the charge. Charge is equal to, by definition, is integral of rho t tau. So rho we know, and t tau we are going to find the volume. This is a small volume element with respect to R only. The volume element with respect to R. So this can be taken as epsilon naught A. Here you take the 4 pi, you are integrating delta Q R uh, integrated over dr. Then you come to next term. Next term, you have lambda squared. I am taking lambda squared outside, and this e power minus lambda r over r inside the integral. That is, this integral is 0 to infinite. Pi t tau, this is a volume is, here we are taking only r coordinate, not theta or pi. So this is 4 pi r squared, that is small area multiplied by the small thickness dr gives you the volume, small volume. Here you can cancel out this r. Maybe I will erase this. Uh, that is, I will erase this dA, dr, d tau. Now I am cancelling this r with this r squared, which will become just r. So you can rewrite this 4 pi. If you integrate the first one, delta, that is Dirac delta function, delta 3 of r dr must be equal to 1. So this will be simply 4 pi. Then what about this? You take this 4 pi outside the integral. So you will get 4 pi. Already there is a lambda squared r e power minus lambda r d r. So here we know the using payment technique. I have given one lecture on payment integral technique. So 0 to please refer that lecture. That is integral between 0 to infinity x power n e power kx dx is equal to, the result of this integral is n factorial over k n plus 1. So now you see here x is replaced by r in our case. You replace the x is replaced by r. So here also r x. Then what is k? K is lambda. K is lambda here. And what about n? R power n. Here r power n. N is equal to 1. N is equal to 1. Then you apply this here. So n factorial is 1. So if you integrate this n factorial, of course you have 4 pi lambda squared, n factorial is 1. So 1, sorry, 1 factorial is 1 over k is lambda, lambda n plus 1. 1 plus 1 is 2, lambda squared. So here this lambda squared will get cancelled with the lambda squared. You will get 4 pi minus 4 pi, as that is, of course you have epsilon naught a, 4 pi minus 4 pi is 0. So the total charge is 0 in this case. Subscribe to my channel to get my latest videos, and join my channel to support its growth and enjoy the exclusive perks. Also use the thanks button to make one-time contribution and support my channel. Thank you very much.